Good afternoon, everyone. The bridges we cross, the buildings we enter, and the tunnels we pass through have something in common that is concrete. But concrete is the foundation of modern civilization. But this foundation have a weakness. Concrete cracks. So when it's crack, we repair it, it crack again. So this cycle continue. I want to break the wall of endless repairs. As you can see in this crack, when it started, uh, it caused the damage. We try to repair that damage, and it cracks again. So this cycle continue. We repair the crack today, it comes again tomorrow. Billions of dollars has been spent on this crack repair technology, but it's still coming back. So instead of asking a question that how we can better repair the cracks, I think about different question that how a concrete can repair itself. This technology already exists. There are numerous bacteria which produce limestone and heal the cracks. But there is a challenge that the concrete environment is so harsh. So when the bacterial spores there couldn't survive because of high pH, because of limited nutrition. So, so the many bacteria dead before it produce calcium carbonate precipitation. So I got a solution that I combine nanotechnology with the biotechnology, and I use nanomaterial to protect these bacterial spores. So these nanomaterial act as microscopic bodyguard, and it protect the bacterial spores so that it can perform well. And we have already so it perform well, it protect the bacterial spores, bacteria produce better limestone, and we have already validated this technology in our lab. We have recorded better self-healing by using nanomaterials, and we have moved one step forward for the practical application. And I think the future is not about producing strong concrete. It's about producing concrete which can self-heal. Thank you.
Thank you very much. Any questions?